Nuclear energy is the energy stored within the nucleus of an atom. Currently, all of the nuclear energy we use for generating electricity comes from the process of nuclear fission. According to Hiberlin 43, electricity as we commonly use, it is the flow of electrons. Fission, as defined by Dahl 561, is the breakup of nucleus into two medium-weight parts. In the case of nuclear fission, it is the breakup of a larger atom into two or more smaller atoms. According to Dahl 561, the first large nuclear power plant in the United States is located near Pittsburgh, Pennsylvania. This power plant used enriched uranium-235 as its fuel source. The fission of the uranium atom releases tremendous amounts of energy that is used to then generate electricity. Then, the electricity is produced from turning water into steam and then having the steam push a turbine. While the process sounds like a normal steam engine, the process to accomplish this in a nuclear power plant is much more intensive. In school, we are taught that water boils at 212 degrees Fahrenheit. The nuclear power plant, as drawn and photographed by F.R. Grodger Jr., uses pressurized water at a temperature of 542 degrees Fahrenheit and a pressure of 2,000 pounds per square inch to start the generation of steam. Beyond the nuclear reactors designed and built to produce electricity, there are also research and test radioisotope production and/or education, as Angelo 366 stated.
Based on a great web page of Zachary Kling, it has been over a century since science began working to harness the energy stored in atoms. Humanity has learned to not only split the atom, but in certain circumstances, combine atoms together into larger ones. With the destruction of Hiroshima and Nagasaki, the atomic era was ushered in. Medical treatments, including cancer treatments, have saved many lives that otherwise would have perished. The world has undergone great changes throughout this last century. In today's world, the benefits we receive from nuclear energy are sidelined in favor of a focus on the setbacks from this technology. In reality, nuclear energy is extremely beneficial, and this is just too important for humans to neglect using it. Nuclear energy has the potential for generating huge quantities of cheap electricity, treating alignments, advancing our transportation system, and expanding our knowledge for the universe through organizations like the European Organizations for Nuclear Research, or CERN for its French naming origin, as well as improving the general welfare of mankind.
There are two fundamental nuclear processes considered for energy production. These are the fission and the fusion. The word fission is defined by the Merriam-Webster dictionary as a splitting or breaking up into parts. Nuclear fission releases heat energy by splitting atoms. The surprising discovery that it was possible to make a nucleus divide was based on Albert Einstein's prediction that mass could be changed into energy. In 1939, scientists began experiments, and 1 year later, Enrico Fermi built the first nuclear reactor. Nuclear fission takes place when the large, somewhat unstable isotopes, or the atoms with the same number of protons but different number of neutrons, is bombarded by high-speed particles, usually neutrons. These neutrons are accelerated and then slammed into the unstable isotope, causing it to fission or break into smaller particles. The word fusion means merging of separate elements into a unified whole, and the nuclear fusion refers to the union of atomic nuclei to form heavier nuclei, resulting into the release of enormous amounts of energy. That is according to the Merriam-Webster's dictionary. Fusion takes place when two low-mass isotopes, typically isotopes of hydrogen, unite under conditions of extreme pressure and temperature. Fusion is what powers the sun. Atoms of tritium and deuterium, or the isotopes of hydrogen, hydrogen-3 and hydrogen-2 respectively, unite under extreme pressure and temperature to produce a neutron and a helium isotope. Along with this, an enormous amount of energy is released, which is several times the amount produced from fission. Both fission and fusion are nuclear reactions that produce energy, but the applications are not the same. Fission is the splitting of heavy, unstable nucleus into two lighter nuclei, and fusion is a process where two light nuclei combine together, releasing vast amounts of energy. Fission is used in nuclear power reactors since it can be controlled, while fusion is not utilized and produce power since the reaction is not easily controlled and is expensive to create the needed conditions for a fusion reaction. Research continues into ways to better harness the power of fusion, but research is in experimental stages. While different, the two processes have an important role in the past, present, and the future of energy creation.
Advantages of nuclear power. The generation of electricity through nuclear energy reduces the amount of energy generated from fossil fuels, coal and oil. Less use of fossil fuels means lowering greenhouse gas emissions. Currently, fossil fuels are consumed faster than they are produced. So in the next future, these resources may be reduced or the price may be increased, becoming inaccessible for the most of the population. Another advantage is the required amount of fuel. Less fuel offers more energy. It represents a significant save on raw materials but also in transport. Handling and extraction of nuclear fuel. The cost of nuclear fuel is 20% of the cost of energy generated. The production of electricity is continuous. A nuclear power plant is generating electricity for the most 90% of annual time. It reduces the price volatility of other fuels such as petrol. This continuity benefits the electrical planning. Nuclear power does not depend on natural aspect. It is a solution for the main disadvantage of renewable energy like solar energy or eolic energy, because the hours of the sun or wind does not always coincide with the hours with more energy demand. It's an alternative to fossil fuels, so the consumption of fuels such as coal or oil is reduced. This reduction of coal and oil consumptions benefits the situation of global warming and climate change. By reducing the consumption of fossil fuels, we also improve the quality of the air, affecting the disease of quality and life.
Not everyone believes that nuclear energy should be used. Despite the advantages offered by harnessing it, there is always the chance that a natural disaster can damage a nuclear power plant, causing harmful radiation to leak out into the surrounding environment. Specifically, as seen by the potential damage from tsunamis, many nuclear power plants around the world are susceptible to the effects of tsunamis because they are located by the sea, from whence they extract their cooling water. This fear of a tsunami damaging a nuclear power plant was, at the Fukushima nuclear power plant in Japan, shown to be an actual threat. Back in 2011, a tsunami struck Japan and damaged the Fukushima nuclear power plant. Radiation from the reactor leaked out into the Pacific Ocean located next to the plant. The impact is seen in the elevated levels of radioactive isotopes seen in fish such as tuna and the nearby waters. Besides the concerns surrounding the environmental impact of nuclear energy, there is the fear of being annihilated by it as well. This concern comes from the vast quantities of nuclear weapons possessed by nations around the world. The system of the Mutually Assured Destruction, or MAD, was a powerful deterrent against their use by either the Soviet Union or the United States during the Cold War. Unfortunately, the threat of nuclear destruction does not have the same deterrent potential against rogue regimes like North Korea's or Iran's Angelo 376. Following the September 11th attacks on New York City, there has been a growing fear that terrorists may one day get their hands on a nuclear weapon. The consequences of a terrorist group setting off a nuclear device inside of a city would be felt all around the world by governments and economies alike. Unfortunately, the threat faced by nuclear energy cannot be completely prevented. Human error in natural disasters will continue to cause accidents like with any other power source. Eternal vigilance is the price we must pay as a species to continue to meet the growing needs of the future.
Utilizing nuclear energy is needed if humanity is to continue its advancement. It has great potential to be quite a useful and beneficial of humanity's growth and development in the decades to come. The problem is, when we lose our respect, caution, and give it to our nativity and arrogance, a devastating disaster awaits us, and it is callous in the destruction it causes. It is extremely important that nuclear power plants be held to stringent safety standards. Nuclear weapons need to be well maintained and kept secure to prevent disasters. Despite this risk, we should not rule out the use of nuclear fission and potentially nuclear fusion in the future, as impractical. The ability to treat disease and generate tremendous amount of electricity with relatively very little fuel is not insignificant. Their application to science and mankind, future space travel, as well as more diverse applications such as nuclear desalination plant, is too great to be overlooked.